So in question 1, we are asked to describe how a stratified sample of 40 students could be taken from this information. So for 3 marks, we definitely need to be working out some numbers. So let's do that first. First of all, our total, we have 140 students. Our sample needs 40, so we break it down into year 12 and year 13. For year 12, we need the proportion of year 12s who are in the year group, in the college, are 84 out of 140. That's the proportion of year 12s that there are, and we need that proportion of the sample. So that gives us 24 students. For year 13, that's the proportion of students in the college who are year 13, 56 out of 140. We need that proportion of the sample that we want. So we definitely need to be finding those numbers. But we're also asked to describe how the sample could be taken. So first step in stratified sample is identify how many from each strata, from each layer. And then within each layer, we need a random sample, okay? So to describe a random sample, label the students from 1 to 84, generate the 24 numbers between 1 and 84 on a random number generator, select the students associated with those numbers. Do the same for year 13, okay? This time label students from 1 to 56, generate 16 random numbers, select the year 13s corresponding to those numbers. Now, this is a bit of a belt and braces approach to answering this question for 3 marks. The mark scheme is this: you need to be clear that you are labelling each year group, okay? As in, we're labelling the year 12s from 1 to 84, we're labelling the year 13 separately from 1 to 56. We need to be clear that we are using random numbers within those year groups, okay? And we need to state these numbers: 24 year 12, 16 year 13s. In this particular question, we don't need this select the students associated with those numbers. You wouldn't lose marks here, but in other such questions describing how a random sample can be taken, we need those 3 points. So in part B, we are given the equation of the regression line for performance related to sleep, P on S. We want to describe the effect that an extra half an hour of sleep may have. What they are testing here for 1 mark is, do you understand this model, using this linear equation as a model, that as S increases by 1, P increases by 5.6. This is like y equals mx plus c, m is the gradient. Here the gradient of the line is plus 5.60. So for 1 hour extra of sleep, we would expect potentially the performance to increase by a score of 5.6. So for half an hour extra of sleep, we would expect an increase of 2.8. It's an increase because it's a positive gradient, and we've just gone along half, added half an hour on, so increased by 2.8. So in terms of describing limitations of the regression model, here we are looking at performance related to, dependent on sleep. So we could talk about other factors being involved, how your performance might not purely be related to sleep. It doesn't take account of other factors such as amount of revision or practice. So we could look at wider factors from sort of our own general knowledge. Alternatively, we could view the kind of what the model looks like here, and so we can see it would be something like this, and it might be that we can look at the minimum value here of P in this model is 26.1. So regardless of sleep, this model is saying that you can't score lower than that. The model also, the line just sort of carries on going in this model. There's no restrictions on it. So potentially we could be saying that the score here might give us more than the maximum score on the test. So there's quite a number of different answers that you could give. Here are a selection of the answers from the mark scheme. There potentially could have been others as well. Be careful here where it says B0, so you wouldn't get marks for saying something like there might not be a correlation, or individual student performance may vary. In particular, that last one, if the student performance may vary, well, we expect it to vary. That is part of the model. It's like a line of best fit. It doesn't mean that it's going to exactly be on that line.